Hello friends, today I want to start a new topic in CSIR NET mathematics examination, which is real analysis. It is also a weightage topic, and if we cover this topic, then uh, you can get more and more number in NET examination. So in CSIR NET, so in real analysis, the topic first of all I want to choose is point set topology. Okay, or you can say it's the basic of real analysis. Okay, where order properties of real number. In order properties, first of all, bounded subset of real number, supremum and infimum, and properties of supremum and infimum are coming. So initially we have to know about bounded subset. What is bounded set or bounded subset? Before understanding or before knowing the bounded set, we have to know about upper bound and lower bound. Okay, so what is upper bound? Let H be any non-empty subset of real number. A real number alpha is said to be a upper bound of H if x less than or equal to alpha or all x belongs to H. Also, if H has an upper bound, then we say that H is bounded above. What is the meaning? Meaning is that H be any non-empty subset of real number. It can be any subset, but it is non-empty. Then if we get any real number alpha, okay, then this alpha is a upper bound of this subset S if x less than or equal to alpha for all x belongs to S. Meaning is that if we take all the element of the subset that we take from real number, and for all the element of this set, that real number we get alpha is always greater than or equal, sorry, less than or equal, means alpha is always bigger from this element, then it is the upper bound, and the set H is called the bounded above set. Okay, and similarly for the lower bound, you can say the same definition, that H be any non-empty subset, and in real number beta is said to be lower bound when beta is less than or equal to x, means for all x belongs to S. This means that for all element or for all x, this x is always bigger than this beta. It can be equal but more bigger from this beta. Okay, then the set is called the bounded below set. It's okay. Now the definition of bounded set. What is bounded set? A subset S of R is said to be bounded if it is either empty, okay, or it is non-empty set and bounded above as well as bounded below. What is the meaning? Meaning is that it can be empty set. Empty set is bounded. This is backwardsly or trivially true. But for the non-empty set, it is bounded above as well as bounded below. Then it is called the bounded set. That means H is subset of real number. It is bounded if these two property are hold. First one, H is empty, then it is also bounded. And secondly, if alpha and beta to number from real number, and this x for all x belongs to S, this x is between alpha and beta, then we can say it is a bounded set. Now some important properties on it. First properties, if H is bounded above, then H must have infinite number of upper bounds. Means you can see here it is bounded above by alpha. Then what is the value of alpha? It can be 5, 6, 7, 8, 9, 10, anything. If x is less than 5, then it can be, for example, you can see x less than or equal to 5. Okay, so this is, if this is true, then x less than or equal to 6, it is also true. x less than or equal to 7. This is also true. So there is no limit of upper bound. That means there can be infinite number of upper bounds. Am I right? Next, H be a bounded below set, then H must have infinite number of lower bounds. Similarly, if 5 less than or equal to x, okay, that means this value of x is minimum 5 and maximum I don't know, then it is also minus 3 less than or equal to x, am I right, or minus 2 less than or equal to x, am I right? So this want to say this by this line. Okay, next, upper and lower bound of S need not be element of the set. Yes, like x belongs to S is a set which is a comma b, okay, or a comma b is equal to 2 comma 3, then obviously x belongs to S. For all x belongs to S, x less than or equal to 5, but 5 is does not belongs to 2 comma 3, but also it is upper bound. So you can say upper bound or lower bound, anything, it is need not be the element of the set. Next example, H be any subset of real number and a less than b, okay, and H is equal to open interval of a comma b and a be real number, okay, then set of all upper bounds is b comma infinity. Now you can see here infinite number of elements are here, and set of a lower bounds is minus infinity comma a, means this is a, this is b. Then if this is your set, then this is your upper bound and this is your lower bound, this is upper bound, and this is our set, okay. Also another example, H1 is equal to 1 half, 1/3, 1/4 and so on. Then set of upper bound is, now you can see this set are belongs to 0 to 1, am I right? Because it is 1, this is half, this is 1/3, this is 1/4, this is 1/5 and so on, up to 0. This is belongs to this, so this is your upper bound, this is your lower bound. So upper bound is 1 comma infinity, lower bound is minus infinity comma 0. Next example, H is equal to natural number, then upper bound is in 5 and lower bound, because it is 1, this is 2, this is 3, so this can be the lower bound, but upper bound I don't know. So upper bound is 5 empty and lower bound is minus infinity comma 1. Now some important topics, which is supremum. Are you know what is the supremum? Supremum means least upper bound, means H be any non-empty subset, non-empty bounded above superset, subset, then the supremum of H is the least upper bound denoted by sup S. What is the meaning is? Supremum is denoted by U, and if and only X is upper, U is upper bound. First of all, you have to be upper bound, and secondly, V is any upper bound of S, then U is less than or equal to V. That means U is upper bound, and for any another upper bound V, it is equal to V or it is bigger than V. That means U is the least. Then this is called the supremum. And similarly for the infimum, H be any non-empty bounded below subset of R, then the infimum of H is the greatest lower bound of S and denoted by infimum of S, okay. And infimum of H is equal to W, then W is less than or equal to X, means this is lower bound, because this is the rules of lower bound. And secondly, if we get any M and which is also a lower bound, then it is this for all M, but for all arbitrary M less than or equal to W, means this lower bound W is equal to M or greater M. Okay, then it is called the greatest lower bound or infimum. Next, the order completeness properties. Every non-empty bounded above subset of R has a supremum in R. If it is bounded above, then it has a supremum, and if it is bounded below, then it has a infimum in R. It is very easy. Okay, now some notation you can see. US means in my lecture I want to define US means the set of all upper bound and L of S means set of all lower bounds. Okay, for example, H is equal to 1 by N. H means 1 half 1/3. Okay, so US means set of all upper bound of S. So upper bound 1 comma infinity, and set of all lower bound of S, which is LS, equal to minus infinity comma 0. And supremum of S is supremum is 1 and infimum is 0. 1 is belongs to the set, but we know in the set 0 does not belong. 0 is the limit of the set, but does not belong to S, and so that's why infimum or supremum can be present or does can't. Next, an example: A and B be subset of R and A is less than B, then supremum of AB can be supremum of closed open A closed B, or closed A open B, or open A open B, which is equal to B, and infimum of AB is equal to infimum of closed A open B, open A closed B, or open A open B. This is A. Okay. Now some important result on it, and then we leave it. Okay, result. First result: A is any non-empty bounded subset of real number, and A belongs to R minus 0, also defined by A plus S, where A plus S belongs to capital S, and AS means AS, where S belongs to capital S. Then supremum of A plus S is equal to A plus supremum of S, so infimum of A plus S is equal to A plus infimum of S. If A is positive, then supremum of AS is equal to A into supremum of S. If A is negative, then supremum of AS is equal to A into infimum of S. It's change. Okay, if A positive, then infimum of AS is equal to A into infimum of S. It doesn't change, but if negative, then it's change. That means A into supremum of S. And also second result: A and B be two bounded non-empty subset, then supremum of A plus B we can write supremum of A, supremum plus supremum of B. Infimum of A plus B we can write infimum of A plus infimum of B. Supremum of A union B we can write maximum of supremum of S comma supremum of B, and infimum of A union B we can write minimum of infimum of A comma infimum of B. For an example, S is equal to 1 by M, 1 by M, Mn belong to natural number. Then one we can write it separately, 1 by N, such that N belongs to natural number, and 1 by M belongs to natural number. No problem. Even sum of two set. Now A is this and B is this, so you can say 1, 1, 2, 1 by 3, 1 by 4, and so on. 1, 1 by 2, 1 by 3, 1 by 4, so on. Okay. The supremum of A is 1, supremum of B is also 1, infimum of A is 0, infimum of B is 0. Now, so supremum of A plus B, what is supremum of A plus B? Supremum of A plus supremum of B by the formula. So supremum of A is equal to supremum of B is 1, supremum of B is 1, so that's why 1 plus 1 is equal to 2. Now infimum of A plus B by formula, infimum of A plus infimum of B, and both is 0, so that's why 0. Next example: if H is equal to 1 by N minus 1 by M, then we can say H is equal to A plus B, where A means 1 by N and B means minus 1 by M. Supremum of A is 1, infimum of A is 0, supremum of B, this supremum of B is 0, and because this is minus 1 minus up minus 1 by 3, supremum is 0 and infimum is minus 1. Okay, so supremum of A plus B means supremum of A plus supremum of B 1 plus 0, this is 1. and 0 plus minus 1, this is minus 1. This is our answer. Okay, now one next and final question. Okay, this question I'll cover in the next video. So from here I want to stop it. Thank you for watching.